All right, class, in this video we continue our discussion of section 4.5 on solving exponential and logarithmic equations in your textbook. So in this video we're starting at the top of page 3 of your lecture handout. So we're going to solve another type of exponential equation for the variable x. In this example we have 2 raised to the 2 raised to the 5 minus 7x power is equal to 15. So we got to find the value of x, put in the exponent up here, so that 2 to whatever this value is equal to 15. So the exponential is already isolated on the left hand side, so we don't have to isolate it. And so the first method in solving this equation, we're going to go from exponential form to logarithmic form, right? We learned how to do that back in section 4.3. So in our exponential equation, 5 minus 7x is the exponent, 2 is the base, and so the exponent 5 minus 7x is equal to log base 2 of 15. Now we got to just solve for x. So subtract 5 from both sides, and we have minus 7x is equal to negative 5 plus log base 2 of 15. Now when I'm dealing with logarithms, you could have wrote this as log base 2 of 15 minus 5, but sometimes students will end up subtracting 5 from the 15 here, and that's wrong. So I often like to, whatever I add or subtract from both sides, I often like to put it in front of the logarithm, so I don't end up doing something like subtracting 5 from 15. That would be wrong. So minus 7x is equal to minus 5 plus log base 2 of 15, and now we divide both sides by negative 7, and we get x is equal to negative 5 plus log base 2 of 15, all divided by 7. Now, so this is an exact solution, and if you got log base 2 of 15 on your calculator, right? If you can calculate a log in any base on your calculator, you got software, right? Then you can just calculate log base 2 of 15 on your calculator, subtract 5 from it, divide by negative 7 to get the decimal approximation. But if you're like me and you don't have the software on your calculator, you got to use the change of base formula from section 4.4. And remember, the change of base formula uses either the common logarithm or the natural logarithm. And so log base 2 of 15 is equivalent to the common log of 15 divided by the common log of 2. And so I replace log base 2 of 15 with common log of 15 divided by common log of 2. And this gives me another representation for the exact solution. Well, if instead of using the common log, I use the natural log, right, in replacing log base 2 of 15, I have this exact answer, this exact solution to the problem up above. And so as I get written down here at the bottom, okay, all 3 solutions above are an exact solution to the original exponential equation. Okay, all 3 are valid representations of the exact solution to the original problem. But there will only be one decimal solution. It doesn't matter which of the 3 you use, right? You should get the same decimal answer for all 3. And so log base 2 of 15 is equal to the common log of 15 divided by common log of 2, which is equal to the natural log of 15 divided by the natural log of 2. And so all 3 of those are equal to 3.906890596, right? 9 decimal places. And so when you replace all 3 of these with this number, right, now we're going to get the decimal approximation. And so you subtract 5 from this number and divide by negative 7, and we get the decimal approximation to the original problem is 0.156158. So if you put in 0.156158 in for x up here and simplify the exponent and raise 2 to that power, the left-hand side will equal 15. So converting from exponential to logarithmic form is one approach to solving this problem. I'm going to show you a second approach to solving this problem. Again, here's our original exponential equation. 2 raised to the 5 minus 7x power is equal to 15. Another method is to use the power rule of logarithms. We can take the common log of both sides of our exponential equation. Remember, the exponential is already isolated on the left-hand side, so we take the common log of both sides. And so because the left-hand side equals right-hand side, we can do that. And so 2 to the 5 minus 7x becomes the argument inside the common log on the left-hand side, and 15 becomes the argument inside the common log on the right-hand side. And now from section 4.4, right, we can apply the power rule of logarithms. We got the common log of 2 to the 5 minus 7x power. This 5 minus 7x can be brought down in front of the log by the power rule, and we have 5 minus 7x is times the common log of 2 is equal to common log of 15. And now we divide both, to undo this multiplication, we divide both sides by the common log of 2, and then we subtract 5 from both sides, and we get minus 5 plus common log of 15 over common log of 2, and then we divide both sides by minus 7, and guess what? We end up with one of the same exact solution to this problem as right here. Okay, so instead of converting from exponential form to logarithmic form, you can just take the common log of both sides, apply the power rule of logarithms, and get the same exact solution as up above. Now, a third method is, instead of taking the common log of both sides, you could take the natural log of both sides. And if you use the natural log instead of the common log, you'll have natural log of 15 divided by natural log of 2 down here.